Uh, Good morning, good afternoon, good evening. This is the EK Math Academy greeting you. Welcome to this channel once again. Today's topic, we're going to do IBDP past paper questions on integration by parts. And before we do the details of everything and do past paper questions, I would like to review some few things you need to know. Okay, so we're going to go through this document. The past paper questions are here. I have very many of them. But let me first review some basics that you need to know about integration by parts. So you need to know what is it. Mainly, you have to know what is integration by parts. What does it do? How does it help you? Now, how do I use it? You know, that's very important for everyone to know. Now, for integration by parts, first of all, what is it? It's a technique used whenever we are integrating, when we are integrating and we have dealing with the product of two functions. For instance, you are integrating x sine x d sine x dx. Okay. For instance, if that's the question you're dealing with, so how do you do? You have x and you have sine x. There are two functions that you are multiplying. So if these are the two functions you are multiplying and you have to integrate, so that's the first thing you should be paying attention to. So integration, what is the integration by parts? In a simple words, I can say integration by parts is a technique used to integrate products of two functions. That's point number one. Now, how does the technique use? Mainly, this is what you have to know. It's used by applying this formula. U dv equals to uv minus integration of v du. It's the reverse of product rule. Do you remember product rule, guys? U derivative, if I can write it in simple terms, u derivative equals to u derivative v plus v derivative u. So when you rearrange this, you'll be and you rearrange and then reverse. That's how we end up coming with this one. Okay, very good. So that's the formula. I'll go. Just be patient with me. I'm going to go step by step, and I'll help you to fully understand how to apply the formula, how to identify that this is the formula you're going to use. Okay. Mainly, I'll help you to know how do I know that how it's integration by parts I have to use. How do I apply the formula? And then I do past paper questions, okay? Now, this is the formula. Keep this in your mind. Note it down by now. If you have a book or a paper or you're revising, please pay attention to that. It's integration u dv minus uv, u dv equals to uv minus c integration of v du. Is that okay for everyone? Very good. I'm going to explain how do you know you're going to use it. When do we use this integration by parts? Okay, I've already said that we use it when we are multiplying two functions. That's the point number one. You apply it when you are multiplying two functions. Here, for instance, so you are multiplying a polynomial and an exponential. E.g., this is the x, e power x. For instance, you have x squared, another example, x squared e power 2x. You are dealing with this is a polynomial, then this is an exponential equation. Or when you are multiplying a polynomial and trigonometric function, e.g. sine x, x sine x, or x squared sine x squared cos x. Any value, as long as you're multiplying two functions, and one of them is a polynomial and another one is the trigonometric function. Now, another way we use it, okay? Logarithmic functions or anything, like this. Integration of ln x. By the way, very common in the exams. This is another example. Or you're dealing with x ln x. You're integrating this, okay? If you have to integrate that, you see, it is a polynomial, algebraic expression, and ln. So the x here, don't forget that. Very good. Or inverse trigonometry and anything, arc tan x, arc sin x, arc cos x, and you have x here. Or even if you have integration of arc tan x, only that you can be asked to integrate that. You can be asked to do integration of that. It's very important and very common. By the way, one of the questions I'm going to do will be having that. So when do we use it? We use it when we are multiplying two functions. Do you understand, guys? Very good. That's point number one. Number two, there's another hint. Point number two, very important. Note down these two. One, when you're multiplying two functions, these are the examples you can use. But there is also another important thing. Do you know what is it? Now, you are multiplying two functions, but I gave you the formula. Do you remember? The integration of u dv equals to u v minus integration of v du. So you apply this formula by identifying which one is going to be u and which one is going to be dv. Okay? Let me explain this to the next page. Okay? Now, I'm going to do it here. Now, to apply this formula, for instance, for example, I have this. I'm integrating this. Let me assume this is the one I'm integrating. I have to know, I have u dv. I have to know which one is going to be u and which one is going to be dv. Am I talking to someone here? Okay. Now, if that's the case, which is going to be u? Now, listen carefully. There is what we use here. Did you see that? Liet, logarithmic function, inverse trigonometry, algebraic expression, trigonometric function, exponential function. The order matters. Whatever you meet first, that's what's going to be a u. So logarithmic function being the first. So if you meet with logarithmic function, that's going to be a u. If you meet with the inverse trigonometry, that's what's going to be u. So what you meet first, that's what's going to be u. So let us take an example here. I have x e power x. So e and x, which one comes first in Liet trick? What comes first? So what comes first is the algebraic expression. So my u is going to be that. Which is going to be dv. Well, what stays? What is staying now? What is staying, guys, is going to be e x dx. Do you get that? I hope you have started picking an idea. Let us go to the second one. What if I was integrating this? Which one is going to be u and which one is going to be dv? Are you paying attention to that? Now, u is what I meet first when I'm using Liet. Let us check. I have x, which is an algebraic expression. Sin x is the trigonometric function. So algebraic expression is coming before this. Therefore, x is going to be here. Then sin x dx is going to be your dv. Okay, let us let me try. Maybe for instance here, integration of ln x. Altogether, guys, dx. Which one is going to be u? And which one is going to be dv? U, this time around, we check. Logarithmic function is the first. Ln is the logarithmic function. So it's going to be ln x here. Now, what is your dv, guys? Your dv is going to be dx. Do you get that, guys? It's going to be dx. Do you get that? That's very important. Now, this is another example. I think I picked an idea. X arctan. So x is the algebraic expression. Arctan is inverse. So this time around, my u is going to be arctan x, and then dv will be equal to x dx. Is that okay for everyone? Very good. Now, in addition to this, in addition to Liet, there's another thing that you have to know. All the time, make your u, what you do the derivative and the powers reduces. And the remaining one, when you integrate, it's easier to integrate. Okay? That's another thing. That's what I was talking about here, guys. Yeah? One of them, whenever you do the derivative of that, it reduces in terms of power. For instance, if I have x, I'm integrating x squared sin x, integration of that. Now, which one is going to be my u? My u is going to be x squared. What's going to be my dv? My dv is going to be sin x. Am I talking to someone here? Sin x dx. Now, why this? Apart from using Liet, why? The main reason is because whenever I do derivative of this, the power is power 3, it will reduce and become power 2. I mean, it's power 2 will be power 1, and then even power 0. The power of what we are rating to be u keeps on reducing because you're going to do the derivative. Now, dv, we are going to integrate. And what we are going to integrate should be easier to integrate. Integration of sine x is negative cos x. Integration of cos x is going to be sine x. So it's easier to integrate. Is that okay? Very good. Easier to integrate, dv. Easier to differentiate is your u. And that's and if you use REAT, you're going to fully get it very well without making any mistake. Ladies and gentlemen, here we go. Now, that's the first question now. Can I write REAT here for you? Okay. Now, this is I. Now, and another thing is the formula. Do you remember the formula? It's integration of u dv equals to u v minus integration of v du. I'm keeping the formula here. Okay, very good. Now, when I use the REAT, logarithmic function, this one is not logarithmic function, it's an inverse trigonometry. So that means my u is going to be arc sin x. Am I talking to someone here? Very good. Now, what is my dv? My dv is going to be the x, because that's the only one remaining. Okay, you see here? Now, this time here. Okay, the whole of this is u. What is staying? That is your dv. Very good. Now, after doing that, what do you do next? Because when you check in the formula, I should have v and I should have du. So when you check what I have right now, I have u and I have dv. So I'm missing v and du. So how do we get du? I have to do the derivative. Du over dx. Guys, what the derivative of arc sin x is going to be? 1. Check your formula booklet, guys. Okay? Or if you want to know where it comes from, you can write it in the comments. I can do it and share the details with you. So it's going to be square root of 1 minus x squared. Okay, so now because we need du, so I need to make du the subject. Okay, it's going to be 1 over square root of 1 minus x squared dx. Okay, is that okay, guys? Very good. Now, I've managed to get du. I'm missing v. So how do I get v? You apply integration sign here. You apply integration sign. So when you integrate dv, you're going to have v. So integration here, there is the 1. I can use there's 1 here. So integration of 1 gives you x. So that means I'm going to have that. So you apply your formula now. Okay, if I apply my formula, it's going to be what? It's going to be u v minus integration of v du. Now, what is u? U is arc sin x, then v. This is my v, this is my u. So it's going to be x sin arc sin x. Is that okay, guys? Good. I hope you understand that. Minus integration of v. V is x. What's my du? It's this one times this. Yeah. Because it's from the formula, it's v, which is that, times the du. And this is my du. So it's going to be, if I can write it very well, it's going to be square root of 1 minus x squared dx. Okay? Now, wow, the question is still going. An interesting question for HR with 5 marks. Okay? Now, what is remaining now? How do we integrate that? Now, to do integration this, by the way, by inspection, you can tell this. But let me do it with the u substitution. Now, here, by parts is over, I'm going to do u substitution. Remember, I'm doing by past paper questions, IBDP past paper questions. Now, what's going to be my u? My u is going to be 1 minus x squared. Now, what is the du over the x? It's going to be minus 2x. Ladies and gentlemen, this is one difference between integration by parts and u substitution. For by parts, you make du the subject. For u substitution, you make dx the subject. Okay? U substitution, you make dx the subject. For by parts, you make du the subject. So that means if I make dx the subject, I'm going to have du over negative 2x, which means it will be over 2x, okay? Now, if I finish getting that, I can go back to the end. So it's going to be x arc. I'm going back here. Sine x minus integration of x over 1 minus x squared, which is u. So it's going to be u. Square root of u is same as writing u power a half. Are we together? Times the dx. My dx is the du over negative 2x. Am I talking to someone here? Very good. Now, I want you to pay attention. You see this cancels out with that. And then I can take minus a half outside. So it will give me x arc sine x. Because this is minus, the sign here will change to be plus. Then I'll get integration. There's a half here, guys. Okay, very good. Now, here, u is at the bottom. I take it up. So be negative a half du. Okay, now it's easy now. It's almost done. So I'm going to have x arc sine x. Is that okay, guys? Plus a half. Now, what is that? Remember the rules of integration, the power rule? I'll do plus 1. So that gives me u power a half. Because a half plus 1 gives you a half. Divided by a half. That is like times z 2. Okay? Now, this one cancels out with this. Let me call it a dot here, guys. This is a dot. Let me remove it. Okay? Times a half. I mean times 2. Now, this 2 cancels out with that. So what do I remain with? Okay? The question is over. The question is over here. Now, what do I remain with now? Okay? Don't forget to write plus c here, guys. So I'm going to have arc, x arc, sine x, plus u power half. U power half means square root. Remember what is u? Guys, you remember? This is my u. So it's going to be square root of 1 minus c x squared, then plus, sorry, my bad here, sorry, plus c. Is that okay, guys? Did you manage to get it? Very good. That's the first question. So that is integration by parts. And this is the first question. Next question. Are you ready? You can pause the video. You try the question before you continue. Now, this is the question. Is this question by parts? I'm multiplying two functions, right? I'm multiplying two functions. And remember, react. Okay? This is I. Okay? So I have a polynomial and trigonometric function. So algebraic expression comes first. So u is going to be x. And then dv is going to be sine 2x dx. Okay? Very good. That is it. So what do I do? From by parts, what did I say? After getting u, let me write the formula, guys. udv is equal to uv minus integration of v du. Okay? Now, I have, if you check, I have u and I have dv. I'm missing v and du. So how do I get du? I have to do the derivative. Du over dx will give me 1, right? So du will be equal to dx. Okay? Now, can I integrate that, guys? So it's going to give me v. Now, what's the integration of sine? It's minus cos. So it's going to be cos c, negative cos 2x over 2, guys. Is that okay? I hope you understand what I'm doing here. Now, very good. Now, remember, I have my limits here. Remember that. Good. Now, let us proceed here. Now, can I apply my formula now? Integration of u v minus, dv. No more writing, sorry guys, sorry. dv is equal to u v minus integration of v du. Now, what's my u? My u is if you remember, it's x times that. That means it will give me negative x cos 2x over 2. Am I talking to someone here? Remember the upper limit and lower limit. So it's going to be like this. Now this is pi over. Okay, let me write it much better. Maybe let's see if it's okay. Good. Now my upper limit is pi over 6, right? And then this is 0. Okay, minus b. So this is minus, and there is minus here, so it will be plus. Integration of cos 2x over 2. I can write a half outside here. I hope we are together here. Okay. Then dx, because that is your du. Okay. Are we together, guys? Very good. Remember my limits 0 and pi over 6. Are we together, guys? Very good. Now, next, can I try to simplify this? Because this is fine. Or I can do it on the next line. So it's minus x cos 2x over 2 and my bracket here, pi over 2, over 6, and then 0 here, plus it's a half. What is the integration of cos, guys? It's going to be sine, right? So it's going to be sine 2x over 2, then cross the bracket, right? And then I have my limits. Pi over 6 and 0. Are we together here? I hope you understand what I'm doing here now. What do we do next? Very good. Now, I have to substitute there here. I'll get to negative pi over 6 cos 2 times that. That will give me pi over 3, guys. All of this over 2. Now, when I put there 0, this will be 0, right? So everything goes. That means will be minus 0 plus. Okay. Now, what about here? This is 1 over 4 sine. This is 4 sine pi over 3. Look at that, because this is the pi over 6 times 2. So when you simplify, it gives you that. So now, what is the sine pi over 3, guys? What is it? So when I simplify that, let me start from here. Pay attention to that. You have to know your exact value. So it's negative pi over 6 times a half. I hope you remember that. All of that over 2. Because cos pi, that's cos 60, so it's going to be a half. 0 is gone, plus 1 over 4 times this is the square root of 3 over 2 altogether, guys. Because they told me to show. This is my answer should be that. What do we have here? This is the negative pi over, this is 12, this is times 2, so be 24 here. Then plus square root of 3 over what, guys? Over 8. Okay. Now, basing on what he has proved by that, that's why I can write this one. You can write square root of 3. This is 3 here over 8 minus pi over 24. Are we together, guys? That is it. They told me to show. I've got my 6 marks. Are we together? I hope you have understood. Okay. For this video, let me stop from here. I still have more questions to do. So question 3, there are more 5 questions to do. Only integration by parts. So I'm going to continue them later, but I can stop from here, guys. Thank you very much. Thank you for watching my video. I appreciate that. EK Math, we love mathematics. Thank you. Thank you very much. Okay.